All right, I think we did it. Welcome everyone um, to our first office hours. So this is our first one, so we'll see. We'll probably learn what works well and what doesn't work well. But for now, we have this meeting notes. There's one current question that I'll go over, but you don't necessarily need to write anything down there. We can do ad hoc stuff. But if you do, we'll help make sure that we can time things well so that we don't spend too much time on one question, not get to anything else. The intent here is to help people that want to contribute to Istio contribute. So I am leading this call, but I don't necessarily need to be the only one answering questions. This is about helping people, not about me talking for an hour. So if you know something, feel free to jump in. And this is for everyone, newcomers, experienced maintainers that have advanced questions, anything goes. So yeah, with that being said, we have one question already on there, so I'll get started with that, and yeah, we'll go from there. So I'm going to share my screen as well. Second. All right, so our first question was, where does the XDS server live in the code base? And specifically to add a field to route from virtual service, and I'm not sure where to start. So this is an interesting question. There's maybe multiple different answers. Let me see if I can zoom this in. I don't know how to zoom in. Okay, never mind. Oh, there we go. Okay. So in this folder we have, this is the Istio main code base. We have this architecture folder, and there is, I wouldn't say it's perfect, but there is a bit of information on kind of the overall architecture. So when you say the XGS server, it's kind of complicated. Like really all of Istio is almost in some indirect form like this XGS server. There's kind of 3 parts really, which is like the config ingestion, like where do we read inputs like virtual services, Kubernetes services, etc. And then we have like the translation of those things into Envoy resources, and then kind of the serving layer where we actually take those Envoy resources and send them to the proxy clients. So I think what we were talking about here is this config translation layer. So we have under the pilot folder, which is, if you're not familiar, pilot is kind of the old name for before we kind of consolidate on Istio. Most of the stuff is under networking. So it's very nested, but under a pilot networking core view and alpha one, we have kind of all these different files around config generation. So we have stuff about listeners, clusters, listeners, routes, HTTP route in particular. And I like that I kind of happen to know, and so I would know where to go to look. But in this particular case, if you're trying to add something, I tend to use like a search. Oh, that's a huge bummer. The search window is a different window and doesn't pop up. But like you could search, for example, like weighted cluster, which of course you guys can't see. So that's and like find out where we're setting those fields. And then if you just want to add another field, like you can clearly see where that field is. So I am searching this, sorry that you guys can't see it, and found that, okay, in this route.go file, we're setting weighted cluster. So this must be where we're setting information about route. And so I think you said you wanted to set like cluster specifier. Oh, you guys can't even see the autocomplete. Okay, I need to fix that next time. So like now this could be like where you plug in your new code, right? What I will use all the time is like this, I don't know what it's called. It's Control B on my hotkeys, but I think it's like go to references. So we'll jump to where it's found, and you can see, okay, it's called from here. Where is this called from? Okay, it's called from these 2 places. Where is this called from? It's called from all sorts of places, but most of these are tests. Oh, it's so annoying. You guys can't see that. Let me actually, I'm going to change how I share. Entire screen. All right. This should work better. So like, for example, like this function's called in all these different places, and you can hop around. So that's generally how I kind of figure out the code base, like try and figure out where something I know is, and then just hop around with the IDE. So yeah, did that help? Is there any like more info? You have there? I got a thumbs up. So
Oh,
cool.
sorry, I can talk. Thanks a lot. Yeah, this really helps.
Yeah. Cool. Yeah, that's the only written question. Anything else anyone's interested in talking about? I can just talk for 50 minutes, I guess, but questions are better probably. No, nothing. Mike, I saw you wanted to type something. Anything from you?
Me? No.
Whitney, I see your cursors, people. I know.
Yes, I have a question. I was hoping to find the PR, but I will send the link. I saw that we recently migrated from using the QGen plugin for generating our CRDs, and we're now using the Buff plugin. I'm curious, what was the reasoning behind that transition, and why did you choose Buff?
I think if I understand right, you may be mixing things slightly. So all of our, well, let me go to the API repo so we have something concrete to look at. So all of our APIs are defined by protobufs, right? And protobufs have kind of this concept of plugins that generate code. Like protobufs are really driven by code generation. So like the general idea is that you'd have one protobuf definition and then generate clients for like all the different programming languages or whatever. We only happen to generate things for Go in terms of programming languages because we only use Go, but you could also generate them for, Python, Java, C, whatever. The way that this was done prior to Buff was basically you would have like these crazy like ad hoc commands, like I don't know what exactly it looks like. It's like proto C, like plugin equals, and like these command lines would get like 50 lines long and have like these crazy make files that are really complicated. So what Buff does is really it's just like a tool to orchestrate protobuf stuff. It does a lot of different things like that. We don't use it to its full extent. It does like linting and dependencies, and they even have like some remote code generation stuff. We mostly just use it as like a opinionated makefile for protobuf. So it's much easier. And now you just type, we have this file here that configures all of our plugins, Go plugin, Go gRPC, CRD plugin, and it just kind of orchestrates those so that we don't have to have these complex make files. How the plugins work is that they, the name, it's actually like a suffix of a binary name. So this one's called like CRD, for example. I would have like I think I have it installed. Yeah, so I have a bunch of Proto C, Gen something plugins installed in my system. So I have this one, Proto C, Gen CRD. You can see I just ran it. It doesn't do anything. It only really works when orchestrated through Proto C. The C is proto compiler. I think what it does is like it compiles some things down to some binary and like passes it into standard out or standard in and then expects something from standard out. So it's not really usable on its own without something like that. Now, I think your question was maybe actually why did we transition from some, I forget what exactly what it's called, it's like cube type gen to Proto C Gen CRD, which I think is unrelated to Buff, but I think it was something to talk about there as well.
I was definitely confused. So it's from what you said, I understand that Buff wasn't really replacing anything. It was just a matter of like orchestrating all of the different tools we use already for generation. Okay.
Yeah. Do you want me to answer why we switched to the CRD one as well?
Yeah, that would be great.
By the way, I think I can probably show you what it looked like before Buff. This is this is our makefile before Buff. So you can see it was, you don't need to read it closely to understand that it's not the simplest or most understandable. So all that was replaced by that one YAML file I showed that was like 10 lines. So that I think is a great project. So the other thing though, cube type gen to CRD gen. So we have these protobufs, and at the end of the day, we want to compile them to CRDs, and CRDs use open API schema types. So eventually it looks like this, which is some just open API schema language. So we had in the past, well, let me say, I guess first, most projects that do CRDs, they start with Go as the base, and then there's an existing generator in the ecosystem to go from Go to CRDs. We chose to go with protobufs as the base, and so we can't really reuse that tooling. I don't know if that was a good idea or not, but we made it a very, very long time ago, and the ecosystem wasn't as developed back then, so there was less choices. So we had developed this tool called KubeTypeGen a long time ago that translated these proto schemas into CRD schema. It was fairly inflexible, and so there was a desire to be a bit more advanced in the schema we have. So in Kubernetes, like in Proto, just the basic, like you can say, okay, it's an integer, and it's like this allows integer numbers between 0 and whatever the max int is, but nothing more complex. In OpenAPI, you can represent a lot of different things. Like this list has a max length of 5, or even there's sorry, 1 second, let me find reference. Yeah, so like here we say min length of 1, max length of 256, but there's even this language called CEL, that is, let me see, expression, okay, where you can kind of write these inline expressions that are evaluated in the CRD itself. So this is something that would previously have been done by a webhook, but is now actually done by the Kubernetes API server without having a dependency. So it's all kind of native, and it's more efficient because you don't need a webhook. And if you actually can get rid of the webhook entirely, it saves a lot of operational and security issues. So Kubernetes Gateway API, for example, removed their webhook entirely in favor of Cell. So all that to say is our original generator was not very flexible for a variety of reasons, namely that it was like translating from Proto to this other language called Q, and then translating from Q to OpenAPI, and then post-processing the OpenAPI to fit into CRD semantics, because there's some tricks on CRDs. And it was very hard to pass through like these additional validations through all of that. So eventually what we did was just go take that, replace it with a translator that just goes directly from Proto to OpenAPI, CRDs, and that has support for these kind of special tags. So these tags are kind of how the typical Go struct-based ones work. It's like, yeah, and so we were able to reuse all those logic, like we didn't re-implement all this logic for how to translate this kube builder, min length stuff into OpenAPI. That's all totally reused, even though it's coming from Proto. So that was the context. It's the generator is fairly straightforward, I think. It's in the Istio tools repo. So the motivation really was to be able to get these extra validations, in particular Cell. I show in the Wasm plugin here because we've only migrated, I think, 2 Wasm plugin and telemetry over to these newer validations. But that's mostly just because it's a work in progress, and it's kind of tricky because we don't want to accidentally make validation stricter than it was before, which can cause compatibility issues.
That
yeah.
helps a lot. Thank you.
Yeah, no problem. Thanks to whoever is taking notes. That's useful because I can't type and talk at the same time. Okay, next one, Jeremy. Do we have a running list somewhere? Easy way to know what are top issues in need of refactoring. New contributor wants a quicker path to finding areas that need improvement without having to look through the entire code base or wait for issues to come through. I would say no. We don't have one. There are some issues around like improve this code base, but it's mostly issues from like 4 years ago, and it's all about the operator. In general, I would be a bit hesitant to go open up like oh, this is good first issue, refactor this code base, because it can be tricky to refactor a code base that you're not familiar with. Actually, it's, even though it's kind of seems straightforward. So I don't know. It's my answer. Off the top of my head, what needs refactoring is, I don't know. It's hard to say. Every line of code that wasn't written by me, not invented here syndrome, but that's not a good answer. And it also a joke, by the way, that wasn't clear. So I don't know. I tend to not be too worried about the refactoring stuff. I mean, at some point, like what tends to happen in Istio is we gradually accumulate a bunch of cruft, and then eventually we need to double down and clean things up. But there's not much super obvious low-hanging fruit that I think hasn't been that stands out to me, or definitely not a list. So, well, yeah, sorry, I can't share the doc and, well, I guess I could, but it's hard to show the doc and my screen at the same time. Actually, that's not true. I can pull it over here. There we go. Cool. So let's see. Next one. We have an Envoy filter configuration for route timeout, and we want to configure it from Istio resource, like VS destination rule. How to decide on this situation? How to check which code is responsible? Yeah, good question. So I think there's a few parts. So how to decide on whether you should switch from Envoy filter to first-class APIs? The answer I would say is always yes. Like Envoy filter should be the last resort. It's very problematic, and that it's when it's not performant at no, Keith, this is not Chrome in the terminal. This is multiple different windows. Sorry. Yeah, so it's not performant. It's really hard to use. It's not upgrade safe. You know, it's pretty problematic. So the nice thing though is that if you know what you're trying to configure with the Envoy filter already, then you already know the Envoy field name, and you can do kind of similar searching mechanism. So I don't know exactly what your thing looks like, but I assume it's like idle timeout or something. So I'll look for that. The thing that's tricky is that in your Envoy filter, you might have like idle timeout is looking like this, like idle _ timeout. But in the Go code, it's usually converted to whatever this is called, Pascal case, I think. So you just need to be careful of that. You can also do regex to make it so it can match both if you're not sure. So what this would show us is kind of like all the different places we're setting idle timeout. So there's a lot of different things here. Like here's a test package, it's not relevant. Here's the CRDs. These are also not relevant. It usually can filter to just Go files as well. So like we saw earlier, like all the XGS generation is under this pilot package networking core v1 alpha. So here I can see where it's set in the cluster builder, for example. And let me show a more interesting one though. So here's another one. We can see things are going on with idle timeout. Let's do this one. So here is the TCP proxy idle timeout. We can see it's set based on node metadata idle timeout. So if we want to see like how could I configure this with Istio API, we can go, okay, how does this get set? And you can see this is in the node metadata. The node metadata is like the static config that a proxy has. And so we can jump around like, okay, where is this read and set? And well, this is maybe a more complex one. Like this happens to be set by like this JSON field. Maybe I'm going off the rails here, and this is actually not even understandable at all. Okay, maybe I picked a bad example of a hard one. I can go dig into that more, but I don't want to go off the rails and have anyone follow me. I will say in general, like this approach of like, how do I set a field to look through the code base is probably, like as a user, you probably want to start with the API docs and look for like, search for timeout on virtual service and destination rule and various things, and then go from there. But sometimes it's also, if you know the exact Envoy field, easier to go from there and kind of reverse things backwards, if that makes sense. Yeah, I don't know if that fully answered your question. I can dig into it a bit more, but I guess I have more time than I thought. We still have 35 minutes, so I was kind of thought we were pressured for time. So let me see. So we want to configure the route timeout. Okay, I guess route timeout's a bit different than idle timeout. So like route, based on our first question, hopefully you were here for this. Like a lot of the route code is configured in this route.go, pretty reasonably named. And so just searching for timeout, we can find something in and kind of see.
Yeah, John, sorry to interrupt. So just to be clear, so our doubt is mainly on which resource to be decided. Like either is it good to put in the virtual service or put it into the destination role? So
Oh,
how
so you're
to
talking about a new field.
yeah.
Ah.
Let's say
Um,
ideal timeout only, the example which you took. So if it is ideal timeout of the route configuration in the envoy filter, so how do we propagate to the Istio resource like virtual service or destination rule? Like on what basis we can take that particular option to choose to keep the new field?
I see. Yeah, so, well, let me indirectly answer that and then directly answer this. This also ties back to our first question we had about where does this field live in the code. I do want to say, like, it's good to prototype things, testing out and whatnot, but it's also probably a good idea if you want to add a new field or API to discuss that with the broader community before spending time on code, unless you're also interested in like want to try it out and whatnot. Because what could happen is you spend a bunch of time trying to figure out how to add this field to Istio. Then you kind of talk about the API, and then maybe the API is not something that the community wants to accept. So it's always good to at least open an issue, say, hey, I'm interested in this thing, get some feedback before you start, especially for larger changes, so you don't waste your time. That being said, if for like how we decide on what's in virtual service and destination rule, it's a tricky subject, I think. In general, Istio APIs are kind of decoupled from Envoy, and they're supposed to be kind of agnostic to the implementation. But in practice, they tend to be very much tied to how Envoy works. And in Envoy, there's kind of routes and clusters. And we tend to directly map virtual service to route and destination route to cluster. That's not always the case. There's actually the one violation of this I can think of is there's a hash-based load balancing that ends up impacting route, but it's in destination rule. So it's not necessarily strictly following this, but it does get very tricky if you end up inverting this mapping. For example, if you have a like a destination rule, for example. Oh, take a second to let newcomers in. Are the people not being allowed in? I don't see any requests for newcomers, Ian. So if they are,
Appreciate. I think you already let them in.
Okay,
Sorry.
cool. Yeah, sorry for those that missed this meeting. We kind of messed up the meeting, so it's locked down to my personal room. So next time we'll make it more open. Yeah, so like you can run into issues if you don't follow the mapping, where like a route can point to like 3 different clusters, for example, and those may have totally different configurations. So if you have this kind of mismatch, then you may end up with a case where I configured a virtual service with this setting, but then I have all these different clusters I need to configure, and those clusters are actually shared across different routes. So like, how do I actually manage to apply the settings correctly? In Istio today, there's never a case where like we have some service, say foo, the foo cluster, and that's shared by multiple routes. We never have a case where like we make a per route cluster so that it can have like special config for that route. So it's theoretically possible. There's nothing making that fundamentally not doable, but you'd run into a lot of friction if you were to be the first to invert those, I think.
John, related to this, I mean, how would somebody decide whether they should create a design doc and get it reviewed before this sort of decision is made, or is it always sort of go ahead and open a PR and then follow the comments on the PR?
Yeah, it's a good question. So the longest route of like most steps to do, I would say, is open a PR or open an issue and say, I'm interested in this feature. Get it some feedback there that, it's not like, oh, it's already been done, it's already in progress, this is never going to happen. whatnot. Or if not an issue, just like on Slack, we have contributors channel or like specific groups like networking environments, whatnot. From there, start a design doc, write a bit up, share it with the group. You could even potentially, like, if depends on the scope of this, right? If we're just talking about one API field, it's much different than like, oh, we're going to fundamentally rewrite some huge part of Istio. So like you may actually have a small like doc. I forget what we call them. We used to have like a more formal concept of like small doc and big doc, where one's like just initial direction, and then one's the details. But then once you have the design, like you go actually submit a PR to the API, and then once the API is approved, go take that and do the implementation. That being said, that's like the following every step along the way. For smaller changes, it's very reasonable to skip some of those steps. Like if you're just adding one single field to an API that's not terribly controversial or changing much, and it's just kind of like this new field, it ends up being translated to some envoy field. Just opening a PR directly to the API repo is probably fine. It's a little effort for the contributor to add just one field in Proto. It probably takes 5-10 minutes if you're familiar with the code base and like where to actually go change the API and whatnot. And it doesn't, it's easy to review. The thing you don't want to do is invest a bunch of time on something before you've gotten feedback that it's going to be plausibly accepted. That's the worst case scenario. Is I go spend 100 hours in the Istio code base implementing this cool feature. Then for the first time I present it to the community in some way, and they're like, "Ooh, we don't actually want this." Like, sorry. That's a case we want to avoid. So it's not about having all these bureaucracy and processes. It's really about making sure we're not wasting contributors' time. Cool. I will go on to the next question. So we have any suggestions on how to understand the overall code base for someone who's new to the Istio community? Yeah, good question. So there's a lot of different approaches. I would start at the architecture folder. It's fairly new. We used to have no architecture diagrams at all. So it's not necessarily the most complete, but there's some decent stuff here. For example, in the networking folder, we have this one, which I briefly showed at the beginning, that has quite a bit of overview of like the higher level design of Istio. Quite a few different charts and stuff. There's a giant chart showing like all of these different areas that interact together and a bit of information about them. So this is good for like high level overview. There's also one for kind of the Istio agent component, decent amount of information there as well. So those would definitely be where I would start. The other thing is like setting up an environment where you can run the code and build it and test it, and then just kind of playing around with things is always good. Like usually it's good to start with some goal, not just, it's like a goal of understanding the code base is good, but if you have a goal of I want to understand the code base in general and I'm specifically working on this bug fix or improvement in this part of the code, it gives a good place to just get things centered. It's hard to just go and say, I want to become an expert on the Istio code base. Like Istio code base is very large. It's kind of a hard thing to just digest all at once. I think how most people tend to learn is they say, I want to go fix certificate rotation or something. And they go, snoop around the code, try and find out where the certificate rotation lives. Maybe they do that by looking at existing logs and they see some log line that says like starting rotation or something. And they grep for starting rotation, find the log and just kind of move around from there to see the whole flow of things, check out tests and whatnot. In general, I think people tend to learn by just doing small things in one area, but many times and over time, all those small things add up to understanding kind of most, if not all of the code base. So yeah, but it's also good, to get a high level overview. So like the architecture diagrams you get a little bit of breadth of understanding of things and then some depth in a few particular areas that you're focusing on.
John, if we have time on this call, perhaps we could utilize some of the time remaining to actually point out some key parts of the Istio repo and maybe the API repo and so on. Yeah, definitely. We have 25 minutes, so we actually have a decent amount of time here.
the question I got was, the next one is explain your shell. I don't know if there's specifics here that I can give some info. So there was some question about the prompt here. This is my Kubernetes cluster that I'm currently configured to. So kind, I don't know why they name it that. Oh, it's because my kind always puts a prefix of kind, but my cluster is also named kind. Like, so if I don't know how to list the clusters. But you can see, like, I have a kind cluster. So that's what I'm pointing to in COP and first the namespace I happen to be connected to. This is the folder I'm in. This is the Git repo I'm in. I use ZHS because, I don't know, at some point many years ago, I decided to. And most of this magic here is from something called FZF, I believe, that does, like, it's a fuzzy finder. So if I want to kind of open like the WASM plugin, I can just kind of fuzzy search. It doesn't have to be exact match, and find what I'm looking for. There's some other cool stuff I have. Like, I have this set up to, like, oops. Okay, well, I guess my Kubernetes cluster isn't working. But on my blog, there's some other cool, I don't know, helpers I have for Istio and Kubernetes. If you want to take a look, I'll post the link there. Is this BSPWM? No, this is I3 is my window manager. So it does the tiling and whatnot. Yeah, any other questions on my setup? This is also Goland IDE, by the way, which I highly recommend, or any of the other ones in JetBrains. I think they're quite good, but obviously you can do whatever you want. Yeah, then I will go over the Kubernetes reading code in XDS. Does that sound good to everyone? Well, before I do that, am I going too fast when I discuss things? Because I don't want to just lose everyone. Or if not, when I'm going over the code, at least just let me know if I should slow down or speed up, with a thumbs up or thumbs down, maybe. It's hard to tell when you're not, sitting next to me and I can't see your face of, like, what the hell is going on. So, okay, so yeah, we want to talk about read Kubernetes and generate XDS. So actually, a good point to start here is this architecture diagram, and not the code. We can go in the code as well, but this gives kind of a high level overview. Then we can dig in a bit. So like I said, there's really kind of, like, I like to view it as 3 parts. There's, like, reading the inputs from Kubernetes and various other places, translating them and serving them. So in terms of ingestion, in general, like, we read from Kubernetes, right? We read Kubernetes core types like pod, service, nodes, namespaces. We read also Istio custom resources, virtual service, destination rule, etc. There's a lot of them. I think I said 20 here, but I'm pretty sure I said 40 on my KubeCon talk. So in one of those, I was wrong. There's, like, a ton of resources we read, and we kind of need to manage all of those. So for various reasons, there's kind of 2 separate code paths for all of this, that are largely isolated. One of them is kind of this config store idea, and this is used for pretty much all custom resources, definitely all the Istio custom resources, but also, like, I think the gateway API, which are custom resources, but not under the Istio. And this is really similar to, if you're familiar with Kubernetes Informers or something, like, it provides a interface where we can do list and get of resources, but they're all cached against the kind of local store of the resources. So in Istio, we are virtually never doing a direct call to the API server to, like, get a single resource. We always have a watch set up for all these types, and then everything else is just in memory lookups against those. So a few interesting things about this is that, one, it's abstracted from Kubernetes. So the interface, we actually have implementations that read from Kubernetes, yes, but also from files. So you can read you can run Istio actually without Kubernetes at all and read like a virtual service from a file in YAML format or something. Not common use case, but you can do it. It can also, this maybe is a bit confusing, but Istio is typically an XGS server to Envoy proxies clients, but Istio can also be an XGS client to some other server that sends Istio configurations. So XDS is both the transport protocol of just basically like a generic pub sub of some protobufs. So while when we talk to Envoy, we're sending clusters and listeners and routes, you can really send anything over the protocol. So Istio can act as a client and receive services and virtual services and destination rules from something else. This, again, is a very niche thing. Almost everyone just reads from Kubernetes. So, and then this aggregate, it just kind of joins them all together so that we don't have like 3 clients for a virtual service. We just have one, and it happens to be represented by the others. So that's, like I said, mostly for CRDs. For a variety of reasons, the service discovery stuff happens to be split out, and it's the line between what is and what is getting a bit blurred over time as we're kind of partially moving over to different ways to do things, but haven't changed all the code. So in service discovery, this is basically all the Kubernetes core types, like service, pod, endpoints, namespace, nodes, that give us kind of the service information and endpoint information. So there's kind of 2 of these. There's one for the core Kubernetes and then one for service entries. And then both of these are, I don't think I show a diagram here, but again, these kind of aggregate down into one service discovery interface. So what this does basically is like, okay, like we're gonna take services and endpoints and compute what we call a service instance. You know, we'll take pods and make what we call workload instances. We're gonna do a bunch of joins on these resources and kind of shape them in a way that just can be consumed by later parts of the code. You know, like I said, most of Istio is really just like read all this stuff. It's like 40 different things, and then a bunch of stuff in a magic black box, and then out comes a bunch of Envoy config. So a lot of the code is just about like taking, you know, some different configs, joining them together to some other intermediate state, and then taking that intermediate state and joining it with something else, and just kind of a bunch of different steps to kind of compile really like these inputs into the outputs. Go ahead, Sanjeev.
John, what are all the controllers? These are the 2 controllers relevant to service discovery.
Yep.
What are all the complete set of controllers in
The complete set, it's I'll get there. It's at the bottom of the stock. There's like 20, so there's quite a few.
Okay.
Yeah. Also, one thing I would say is like in other projects, oftentimes controllers seen as like read some Kubernetes resources and then right back to Kubernetes. Istio is a bit different because we do have a few controllers like that, but most of our code is actually read all these inputs and output to Envoy. So there's some differences from kind of a typical controller model. So one of the core areas of how Istio works is this concept of push context. Basically what push context is it pulls from all these different areas I talked about, both the CRDs and the service discovery and like all the entire state of the world basically. And it pulls us all into the snapshot we call push context. So every time there's a change to some of the inputs, like a new service is added or something, we're going to go generate a new push context. There is some logic to make it so it's kind of more incremental, so that it's not just totally, you know, doing a ton of work every time. But logically, it's like a snapshot of the current state of the world. And we do a bunch of pre-computations of things like setting up, you know, index so we can look up a virtual service by host name, for example, or things like that, so that later parts of the code can kind of efficiently use this. So all of the XDS generation is reading this push context, basically. It's not like the XDS code is like directly listing like, I want all the Kubernetes services. It doesn't even necessarily have access to the Kubernetes services because we compile these Kubernetes resources into our internal types like service instance, which is just a type defined in Istio. That's kind of a generic way to represent a service, whether it's from a service entry or from a Kubernetes service, or in theory, a completely different system. Like Istio used to have direct integration with things like Console and Eureka and stuff. So it's kind of an abstract model of a service, not directly tied to Kubernetes. Does this make sense so far? Is this good speed?
Do we do anything with endpoint slices in Kubernetes, or I see you've got endpoints over there?
Yeah, I did put endpoints here. That's probably a bit misleading. I think at this point we only read from endpoint slice. Actually, for a long time we read from both, but now we've cleaned it up. Only endpoint slices. Kubernetes itself has a controller that mirrors endpoints into endpoint slices, so you only really need to read endpoint slices to get the full set of things. One, I guess, minor note, but it's fairly important, is that there is somewhat of a different flow of configuration for endpoint changes in particular. The reason being that endpoints change a lot, right? If you have a steady state cluster, in production, generally the only thing that's going to be changing is pod scaling up and down, which ends up with endpoints changing. Like you're probably not changing your virtual services at 2 a.m. or something. So you generally have only endpoints changing for the majority of the time. Now, if you're in a development cluster or something where you have rollouts going on all the time, that's of course not the same. So we have this path heavily optimized where we don't recompute the push context. Actually, endpoints are stored in this separate system outside of push context so that it can be updated without this more expensive recomputation of the push context. So there's another part of the code that's called like endpoint index, I think, that kind of stores that, and it's incrementally updated based on events from the different service discovery areas. Cool. So that's kind of all the ingestion side, which I'll also go into give some more in the actual code. But that's kind of a high level overview. From there, we have the translation. So various different clients can request various types over XDS. Like usually this is Envoy, and Envoy would request routes, clusters, listeners. But there's other types we support. Like Istio has some custom ones for DNS. For example, we have this resource called a name table. We also have debugging endpoints, debugging types that Istio Cuddle can connect to get like the status of things. So we have this concept of a generator, which is basically this interface that says like, here's how I generate a route. Here's how I generate a cluster. And so when a proxy requests, give me all the clusters, we call the relevant generator and we build the clusters. One thing that's interesting in Istio compared to a lot of other XGS servers out there is that Istio is actually generating resources, these XGS resources on the fly. A lot of other projects, they just build up like a snapshot of like, this is here's all my clusters, here's all my routes, and here's all my listeners. And when someone connects, they just send them down to them. For better or worse, Istio doesn't do that. So the XGS generation has the proxy metadata as an input. So we can know, this specific pod in this namespace with these labels and these annotations is connecting to me. How should I generate a cluster for it? And this is nice because we have a bunch of customizations. Like in particular, a lot of the core APIs work on label selectors. So we say, this authorization policy selects app equals foo. So when we go generate the listener configuration for the foo pod, we know, okay, its labels include app equals foo. So this authorization policy should apply. And so we'll generate the config based on that. There is a downside to this, though, is that one, it makes casting very hard. And so in a typical cluster, almost all of Istio's CPU time is spent on this XGS generation, and in particular, taking the XGS objects and marshaling them into protobuf representation so we can send them over the wire. So there is a huge value in caching. Istio does do some caching by basically saying, like, this cluster is only going to look at, when we generate this cluster, we're only going to look at these specific fields in the proxy rather than whatever happens to be there, and we can look at anything, and we kind of build up a cache key around that. So that's kind of trying to get back some of the performance while still keeping the flexibility we need to implement our APIs. One of the other, well, let me see. I forget. Okay, I think that's, well, you did ask for what all the controllers are, so let me find where that is. I don't think we have time to go over all the controllers, but this chart, this is probably actually too small for you guys to see, I'm guessing. But this chart has, I believe, every controller, at least at the time of writing. And so you can see there's a ton of different controllers. We have, things that read CRDs from files, from memory. We have all these different kind of standalone ones that handle, for example, the ingress resource, that handle virtual machines, that handle and webhooks, like all these different things, and they all kind of come together. So I probably won't go over all that due to time, unless people want. Otherwise, I'll probably go jump into some of the code about the things I talked about. Yeah, Jericho.
Hey, I'm just wondering for like XDS and Envoy, are you like using a Go library? Or are you like using a binary that gets compiled, like when you build Istio? Like, how does that work?
Yeah, so pretty much all of Istio is compiled down to one binary called Istio-D. And we have in that the XDS serving code. Envoy has a library called Go Control Plane that's kind of like building blocks for building your own XDS server. Istio does not use that, though. We have our own implementation of an XDS server. So we've kind of reinvented that to some extent. Although I think Istio was there before Go Control Plane, so maybe they reinvented Istio.
Sounds good. Okay,
yeah.
Thank you.
Yeah, so I guess next we can go into some of the code. This might get a bit complicated, but we'll see what we can do. So I think the most interesting part is the Kubernetes controller. So we have all of our service discovery is under the service registry folder. So I talked about there's a Kubernetes one, there's a service entry one. There's also, I didn't talk about this before, but there's a mock one for testing and a memory one for testing. I'm not entirely sure why we have mock and memory. It's maybe or maybe not a good reason. And then there's an aggregate one that just kind of joins them all together. So in the Kubernetes one, you can see there's quite a few files. This is one of the biggest controllers in Istio. It's kind of grown quite a bit over time, but we can still probably get some useful information out of this. So here is like where we build up the controller. So in Istio, for all of our Kubernetes access, we use kind of this wrapper that we've defined called client. And so in Kubernetes, typically you have like a client for every different type, like one for the core Kubernetes types, one for Istio, and whatnot. The client type that we have kind of just wraps all of these into one thing so that we don't have to pass around all these different clients, and it's just kind of one centralized thing, and it has some nice helpers around things. So that's kind of passed in as well as a bunch of options. Then what we do is we're basically just setting up a bunch of watchers or informers, or again, we have a higher level library on top of Kubernetes informers, which if you don't know what an informer is, it's basically just a way to watch Kubernetes resources and provide a cache over them so that we can do gets and lists against them, but it's all against in-memory data structures, so we're not actually making requests to the API server every time. This is really key to Istio's scalability. If you have reads and writes, or like direct reads and writes to the API server, then you run into the issues like throttling, overwhelming the API server. So we avoid that in almost every case. Obviously, there's other controllers that are actually writing things to the cluster, but those are kind of rare and not on like this hot path of getting a pod update, for example. So this K client thing is just really a wrapper around these informers. It's not doing a whole lot. It just makes it a bit easier that I can really just say, here's my kube client. I want an informer for namespaces, and it does a little bit of magic to figure that out. And there's some like filters and stuff that I think we'll show later. Then we set up some watchers for these. There's just a little helper here that wraps it with some metrics, but really this is saying like for every namespace event that comes in, because again, we're watching these, here's how we should process it. So this one happens to call out to do, namespace is not the most interesting part of this code. So I'll maybe go more in depth on another one. for pods, and a few other more advanced things that it's probably can't cover in 5 minutes. So maybe I'll go kind of more in depth on how we handle a service, for example. So here's the on service event. Function's called every time a new service comes in. And so we have access to the old service, the new service, and the event type, whether it's add, update, or delete. So as I mentioned earlier, Istio has internal representation for the various different types. Like we're not really just directly referencing Kubernetes services everywhere. So one of the first things we do is we take the Kubernetes service type and we convert it to the Istio service type. And so this looks quite a bit like a Kubernetes service, but it's a bit more generalized. So, we have things like creation time, host name, ports, virtual IPs to reach it at, and a variety of other flags. Yeah, Sanjeev?
Sort of a basic thing here, which I want to clarify is that, okay, you could have multiple STOD control planes in the same cluster, and each of those, all the controllers in each of those STODs are listening to all kube events across the cluster, including namespaces that are mapped to the other STOD control plane. Is that a correct view?
Yeah, so with the exception of one or two controllers that I haven't talked about at all in this, all Istios Ds operate completely independently and redundantly, and there's no communication between them. There's no, like, only one of them is processing services, for example. When a service is changed, all the instances of Istio D are going to get that and compute their own internal state. And then a proxy can connect to any of them just by a standard load balancing. And as long as there's no bugs in the system, they should get the same information. I will say in the past, there's been a variety of bugs around different configurations being processed differently by different instances. And then a proxy connects to one, it gets some config, it later reconnects to a different one, gets a totally different config, and like causes an outage or something. That's obviously a bug. We fixed many of them. Probably there will be more in the future due to us not writing perfect code. But yeah. Carl mentioned there is an Istio D leader election. Yes, for operations that we actually write into the cluster, we do have a few different controllers that do writes in the cluster. Those tend to use leader election. I think there might be a few that don't for a variety of reasons. But everything I've talked about today, there's no leader election involved at all. It's totally independently scalable. So you can scale, 100 Istio Ds or one. They should all work the same. The leader election is only for a few different areas.
Is it a leader on a per STOD basis or per controller basis?
The leader elections we have are generally per controller. So I think Keith said on the chat that he was going to be giving a gateway controller in one of these in the future, and that is one of the examples of one that writes to the cluster and is under leader election, so you can make him answer more questions there. We're also somewhat out of time, so I can't go in depth there. Yeah, so we only have like one. Actually, let's stop this because we only have 1 minute left. I guess I don't even have time for last minute questions probably, but I just want to say thanks everyone for coming and letting me talk for an hour. This was our first office hours, so we would love feedback both on, I don't know, if I answered questions terribly or if the whole general idea was good. If we want to see something else, whatever, just let us know on the doc or DM to me, Sanjeev, anyone. And if you are or consider yourself a subject matter expert, then we have a sign-up sheet somewhere. I don't know if we can help you find it. We'd love to have people sign up. I think we're going to do this every other week. So if you're interested in signing up to host, please do so. If you're interested in joining, please do so. And give us feedback and whatnot. We also, you don't have to wait 2 weeks to just ask a question. We also have a contributors channel on Slack, which is pretty good place to ask a question, I think, or obviously GitHub issues and other places. So thanks everyone. I don't know if Sanjeev, you have any other closing notes?
No, thanks. Really, really appreciate, especially big thanks to John and big thanks to all the SMEs that have signed up. We are asking them for their time. but hopefully it will pay back in terms of work that we can offload from them. So thanks, John, and we look forward to your active participation. This can be made to go however everybody feels is useful. Okay, so the more you can give us guidance, the more we can tune it to whatever is most useful. So see you in 2 weeks.